Welcome to the course design of reinforced concrete structures. So, what do we mean by design? Design means to plan or to make drawings for appearance or to show the structure which is not yet constructed. So, the structure which is not built, for that we have to plan, we have to make drawings, and that is called design. And now, the next question, that what is reinforced concrete? Reinforced means actually, as per the Oxford dictionary, it calls that make it stronger. Reinforced means make it stronger, and reinforced concrete we make it with that steel bar. Steel bar, so we make concrete stronger with the steel bars, that is called actually reinforced concrete. So, coming to the point, the design of reinforced concrete structures. So, we have to design reinforced concrete structures. So, that particular one we shall do in this particular course, and one second. Let me be habituated. So, what is concrete? Concrete is made by mixing cement, fine aggregates, coarse aggregates, and I have kept that and water, because water I have kept it. Cement, fine aggregates, coarse aggregates, these are the three materials which we shall consider, but water also is another governing element. If we add water less, then also it will vary the strength of the concrete. If you add water more, then also the strength of the concrete will vary. So, water plays an important role in this particular that concrete making. So, that is why we kept it water. And how do you describe that water? We describe this one as water cement ratio. So, water cement ratio will tell us that whether that particular concrete we shall achieve that target strength. You can find out the steel it is made in the workshop, and it is in a controlled environment, whereas we are talking concrete is made in the field itself. And you can find out that particular one, there are so many factors play while making concrete. We just simply cannot put a particular proportion, and we cannot say that concrete is made. There are lot of other things also. Even the concrete is made, there is one more important part, that is called curing. That means, even if we make concrete, then you have to cure it. Generally, we do it that water. If the curing is done properly, then also we can say that significantly that changes will be there in the strength. So, if we come to this point, just to give this particular one, generally these coarse aggregates made of that stone chips, and this one obviously in that bulk amount, that is the major amount you can say. This one that fine aggregates, and that one we can say this is generally the sands, and which we can get it from the river beds, and the binding materials here, that is cement. And here we are keeping that one, that we have to measure that water also, and this one, that water cement ratio. For a particular case, if we have say 1 kg of say, for this case say cement, then we require say 400 milliliters. Say we are considering water cement ratio 0.4. Generally it comes in that range, 0.4, 0.5 in that range, depending on the target strength. So, coarse aggregates, fine aggregates, cement and water. Please note this particular one, because whenever we are talking say reinforced concrete, we should remember this particular one, what are the three different parts. Generally it comes say 1:2:4. If we consider 1:2:4, that is ratio of cement, concrete, then we mean to say that 1 means cement, 2 means sand, and 4 means coarse aggregates. We generally do not specify that water, we generally specify that 1:2:4, 1:1.5:3. So, these are called different generally that guiding one, we call it nominal mix. So, here we designate M15. If we consider M15, we mean to say that we have to achieve the strength of the concrete after 28 days, that is 15 Newton per square millimeter. Similarly, we specify say M20. M20 means the design mix, M for mix, and 20 means 20 Newton per square millimeter. So, that means we shall achieve that one after 28 days. So, if we test that one on 28 days, we should achieve that particular target strength. Just let me give an example of that, say your slab. This is actually slab, and whenever we specify this concrete, reinforced concrete, then we have these bars, because this one we are considering slab, that where you are sitting or the roof, the top, that is also called slab. Generally, we have 4 components. One is called that slab, another one is called beam, other one is called column, and the column footing. So, these are the 4 components we have to design, and that we shall learn in this particular class. So, slab, horizontal one, just like a plate, beam, horizontal one. So, like this we can say beam, and then we have that one column and column footing, which will transfer the load on the ground, that soil, and that also depends that soil, that bearing capacity, that how much load it can take. If we take say here just only say single one, say very pinned one, then sharp one, then what will happen? It will just simply pierce the ground. So, that we have to make a square type of thing or circular type of thing, so that the load would be transferred to the ground, and that depends on the bearing capacity of the soil. That is another aspect, that means that one will be told by geotechnical engineers who are looking after that soil. So, that is another aspect. So, we shall get the features or properties of soil where we are going to construct that particular building, and then on the basis of that we can find out the footing size. So, I repeat, the number 1, that we have to know how to design the slab, number 2, we have to know how to design the beam, then column, which will transfer the load on the ground, and since the column dimension that is not sufficient, that is less, which could pierce the ground, that is why we are making that column size on the bottom little bigger, which we are considering that footing. Considering this particular reinforced concrete element, this is nothing but the slab element. Here we can have that concrete, then we are having bars in 2 directions, we have bar, and you can see at the top also and at the bottom also, the bars at the top also at the bottom, and these bars you have to specify the dimension, what should be the dimension of the bars, what is the spacing of these bars, what should be the depth of this concrete. We cannot simply provide the bar at the bottom of the slab, we should give little bit of cover. That means, we cannot give that one. So, if you see the slab from the bottom, you cannot see the bars, you have, because it will be little bit up, maybe say 25 millimeter, 30 millimeter, depending on the situation. If the environment, say for normal case, generally we keep say 15 millimeter for slab. If it is say beam, then we have to keep 25 millimeter. If it is say column, then we give 40 millimeter. That means, from the outside dimension of the column, we have to give it inside 40 millimeter. So, that we have to give that particular dimension. Just I can say, if we have say a beam, so this is your say dimension, and let us say we are having the slab, it will start from here. Okay. So, we have to provide the reinforcement, because concrete is very weak in tension. Concrete can take compression, that means if you press it, it can take enormous load, but if you just pull it or bend it such a way, so that the tensile one it is very very less, almost we ignore it, we neglect it, that it means that concrete does not take tension, and that part we just supplement with this reinforcing bars. So, we are having the reinforced concrete, though we are talking say one single element, but it has two different parts. One part is taking compression and another part is taking tension. Tensile one will be taken care of by steel, which is manufactured in the workshop, and compression one will be taken care of by the concrete, which we do cast in the field itself. So, here also you will find out little bit difference, that means one is the controlled environment, another one is the that environment is not so controlled, because there could be so many spurious things can enter to that particular one. But anyway, we shall not take care that particular one, we shall assume that we shall achieve that particular target strength. Now, when we are talking say cover regarding this particular one, so this is called actually this, whenever we are talking this particular one, the bar, that means the bar, the beam is like this, this is your beam, let us say the longitudinal direction. Let us specify something say your axis, that will be then it will be more clear. So, if I say this is your say x, okay, and then we can move this particular one say your y and the other one say your z. So, whenever we are talking this particular one, x means along the longitudinal direction. So, this particular cross section it means we are considering this one as say y and this one we are talking say z. So, is it clear? That means, we mean to say this portion, that is one cross section, and there if we see the bars actually along this direction, and if we take a section, if we look this particular like this, so we have to specify say A. That means, I am taking a section along this particular line, and if you look that one, then I shall see, and this is nothing but say section A. Let us say there are two bars, we are specifying two bars. So, we shall get just two round the circular thing. Maybe it could be say what is the bar diameter. Generally, the bar diameters we are having say 6 millimeter, it starts from 6 millimeter, then 8 millimeter, 10 millimeter, 12 millimeter. So, we can have bar diameter 6 mm, 8, 10, 12, 14 also available, but generally we do not use it, because generally there it is not manufactured in a regular manner. 16, whatever we specify in our say drawing in construction, that only I am telling 16, then 20, 25. So, we go in this particular order. There are so many others also, but generally for our residential buildings, school buildings or the common type of structures, we are happy with this type of bars. Why we need it? That if you do the construction, say the planning, design, all those things done in the say your design office. So, now what you have to do, when you will give the drawing, immediately they cannot start. So, what you have to do, the site, the stores, they will ask for that what type of steel you are using in your design, that you have to specify, because if I give the drawing now, they cannot start immediately. So, they should have to have some tender for say procurement of different materials, concrete for concrete, say stone chips, sand, then your cement, then as well as steel also. So, first thing that steel, because steel that you have to give order, then it will come, it may take some time. So, that is why they ask for that what type of bars you are going to use. Generally, we use for slabs say 8 millimeter, 8 and 10 generally we use it for slabs. Then we start say your beams, we generally start from say 12, 16, 20, that we generally use, and for columns we again use 12, 16, 20, 25. it all depends on the designer also, because every analysis is something you are doing, you are following a method and it is straightforward, and it is, you can say that particular one analysis, that one you can say that almost everybody of us will use the same formula everything. Here also in design also we shall use the same formula, but everybody has its own design philosophy. So, you can find out that there are different school of thought that okay, he prefers this way, the other one prefers, but we are using the same formula. But whenever we are providing, say for example, for slab one can say okay, I shall use only 8 millimeter. A designer may have some kind of allergy of using say 10 millimeter dia bar also. He is always is interested, fond of using 8 millimeter. This is one kind of say philosophy, but there is nothing wrong on it. So, the thing is that 8 millimeter, 10 millimeter like this, but somebody is interested okay, whenever I feel okay, let us use 10 millimeter. Similarly, for say beams, say somebody is interested using say 12 millimeter and 16 millimeter only. Similarly, say your for columns we shall start to, we can start with 12 millimeter, then we can start 16, 20, whatever it is that we can start, we can use it also. So, now coming to the point, I started with that cover. When we told the cover, we mean to say the central line of the bar, from there to the end of this one we shall say that is called effective cover. So, effective cover, it means this one, let us say that is D dash. We can have other one that is called clear cover. So, we have effective cover and clear cover. Clear cover means from the end of the bar, the end of the that section, that is called actually clear cover. So, we have one clear cover and another one is called effective cover. Now, clear cover, let us say, let us make it little bigger then. This is the bar diameter, bar, this is the end of the section. Clear cover we mean and effective cover, it means this is called effective cover. So, what we can do actually here, if we say clear cover say CC, then effective cover will be CC plus diameter of the bar, half of the diameter of the bar. So, phi by 2. So, whenever we calculate that one, so effective cover and clear cover we shall make it like that. We shall come in detail that at the time of design. Now, coming to this particular point, why do we need clear cover? One important aspect, that is your say corrosion of steel, so that the steel is not corroded. So, that is one aspect, and there are so many others also we can find out. From the environmental aspect, that is the major one we can consider, that we have to give proper, we just simply cannot give immediately at the bottom. So, that part we have to consider here. There is one aspect, that is your say, this is your junction, that what we consider here, that this part is called that slab, and sorry, and the other one is called this one is called your say your beams, that beam detailing. and this is your column, and this portion you are having that slab. So, actually I am okay, just a minute, I am just coming. Okay. So, this portion I am not still habituated, right. This portion is called that your say slab, this one is called your say slab and the other one slab, and there is a junction here say. If we consider that particular junction, what we can do here, that if we consider let us say this is a plane and we are considering that 4 different parts, we can make, let us give certain dimension. This one say 10 meter, and let us take this one also say 10 meter. Okay. What we can do here, if we use 10 meter, you can find out that 10 meter of one plate, if we consider, then what will happen? You will get deflection in the middle too much, because 10 meter by 10 meter, that particular one, if you have to make, say maybe you can consider a paper, maybe even if you can consider say cloth itself, a big one, if you just hold it with say 4 corners, then you will find out the deflection at the middle too much. So, what we can do, we can give 2 horizontal bars like this in the middle, so that your middle point deflection is less, and but you will get deflection here also, in these 4 points you will get the deflection, but we can reduce our deflection. So, that means if we can make say here beams, the horizontal one which we call beams. So, if we put 2 beams here in addition to these 4 beams in the periphery, so we can increase the stiffness and we can reduce the deflection, because deflection is also is an important criteria. Now, coming to this particular point, let us say that we shall provide 4 columns say here say like this, and also we can provide here also columns. So, one such example here, when we consider that one such example here, this particular one, if we consider that this column and there are 2 beams, this is one beam, this is another beam, and the one column, that one also intersecting. So, now this one, what happened that we have to provide the reinforcement for these beams, we have to provide reinforcement for these beams, and also you have to provide reinforcement for slabs, and also you have to provide reinforcement for the columns. So, we can find out that it is really a chaotic situation, because there are so many bars you have to provide, and each of them has their own bar diameter. So, when you have to consider that part, and that is called detailing. Detailing is very, very important in reinforced concrete design. Even if you design that one, that also that how to provide the reinforcement, that is very, very important aspect. So, this is one such example that you can see that how the bars are provided, and through these all the bars, and there are so many, also there are some kind of say lapping also you can find out. That means, it is not possible that we shall get one single bar coming from the bottom to top, maybe we shall get say 5 meter or say 8 meter or 10 meter that length, whatever we can get from the workshop. Now, when we are considering that particular bar, that bar you have to provide, so you have, there should be a lapping. So, the thing is that obviously we can understand that if we have say 2 things like this is one bar, this is one bar, and let us consider just with the cord we would like to tie it out. If we make this one small, obviously one can simply pull it and take it out, but so that means we should have some kind of overlapping, and obviously it depends on the diameter of the bar. If we consider say 2 wires, the wires are very small diameter, then we can have say whatever overlapping required. If the wire having the larger diameter, then we need overlapping more. That means, with the cord itself we have to tie it out, and if we pull it so that it will not go out. So, this is called lapping, or and we have to provide the lap length also, so that it will not tear it out. So, these are the different aspects we have to consider in the reinforced concrete design. There is another aspect, this is your column. Another aspect, that bars whatever we are having, we have to provide for the bars, we call it tie. The tie, that means it is tied. These bars are called longitudinal. These bars are called longitudinal, and these bars that called tie. The tie you will provide, we provide ties. So, this is your longitudinal bars which are going up, and we have to provide tie, say like this. So, we have to provide the diameter of the tie bar, and the spacing, this is called spacing. That means, so we have to provide the tie bar and spacing. Okay. So, this one we have to provide, so that if we do not provide, what will happen? If we do not provide, then it may happen that it will bulge like this. So, that is why you have to tie it out, so that it will not go out, it will not separate out. So, this is also you have to provide, and it depends on the your say column dimension, lot of other things. When we shall design that column, that time we shall do this particular aspect. So, this is another one, we are not going to detail of that particular one. This is your that at the construction site, we generally are habituated, we generally see the finished product, but if you see the construction, there are so many things actually there. If you see say this portion, this is one say block, this is another block, these blocks, all those things which are given actually to provide the proper clear cover. These small blocks you will find out at different places, just to provide that one for the proper clear cover. Otherwise, it will be only at the bottom of the that particular say your surface. So, you have to lift it up, and you are lifting up with that say small blocks that is made of say mortar. Mortar is nothing but sand and cement. So, with that we make that particular one. This is your say circular column, and here you can see that this one having say spiral. The tie we are making say spiral one we are making. So, this is another one we generally make that for, and this is actually one they are going to construct circular column. This is your base at the bottom, that footing. After this they will start the circular that your section, and this one obviously we have to use this type of say arrangement, otherwise it is so heavy, you can understand, otherwise that everything will fall down. Your that concrete, because fresh concrete it does not have any strength, green concrete does not have any strength. So, it will simply fall down. So, you have to use these supports to withstand that particular load, and only after say 28 days or maybe after 14 days only you will get the required strength, and then if you take it out then it will. So, generally you have to take it out after 28 days, and then you can see that particular structure that is built, it can take the load for which it is designed. There is another aspect here, that is this is called beam, this one is called column, and this is your say beam. This particular beam has a special name, we call it tie beam. We call it tie beam. So, whenever we are having say this one, we are talking say one elevation, and what we do, this is a ground, what we do, let us say another column is there. What we do, say maybe we can provide here, or maybe we can provide, we shall provide say here one beam, and this is called at the bottom, this one we can provide one beam say at the first floor level, another beam at the second floor level, like that we can go. This beam has a special name, we call it tie beam, and it is rectangular. That means, if you seek the cross section, you will see like this. You can see here also, you can see this is the one, we can see that particular one having say your this particular one here, that one section if you consider, that is rectangular. You can see that particular one say your rectangular, that you can see. So, we can come to this particular one. So, tie beam, that is a special name that we have to consider, and I have already told that your say curing. Curing is generally done like this, that jute bag, all those things, we just cover it and we just put water, and that is called actually curing, and that one we have to do that curing also, that is very very important. Even if you cast it properly, all the cares you have taken care of, even then you will not achieve the target strength for which it is designed if it is not done that curing properly. So, that is very very important. This is another aspect of that from the site, just I have taken this particular one, and here also you can see there the construction is going on in our that campus itself. So, this particular construction, and you can see the tie beams, there are so many tie beams here. So, that one at the bottom, why we need that one, because from there we shall that wall, that brick wall will be started, that particular one we have to use it. Now, coming to the point here, one aspect, that is we are doing the test, we are doing the casting at the field itself, and we know the proportion, let us say M20 grade of concrete. That means, we would like to achieve the target strength, that not target strength, we shall say characteristic strength, we call it. That characteristic strength, that we have to achieve. If we say M20, why I am telling every time M20, because that is the one we generally use. M20 mix 20, that is we generally use for common design, residence building, school building like that, college building. So, any public building, generally we are happy with that M20 grade of concrete, that is a common mix, we use it. When we use that M20 grade of concrete, mix 20 Newton per square millimeter, we have to achieve the strength, that is called the characteristic strength we have to achieve, and that we shall have to find out how do I know that we have achieved that strength. For that, what we do actually, we take, we at the same time we cast 150 millimeter cubes, that 150 millimeter of cubes, that we cast it, this particular one, the 3 cubes that we cast it, at least 3 cubes we have to cast, which having dimension 150 millimeter dimension, and that we have to test, and that we test it with this type of machine. This is your say, we call it say universal testing machine, that is commonly available, that this testing machine, that we can use it for bending, you can use it for say your compression. There are so many others also for tensile strength also, that also you have to use it. What happens actually, if you test it, this particular one you just keep on loading and this one will come, wherever it will have the crack and failure, only it will go up to that and then it will go back. So that we can find out what is the, whether we can achieve that, what is the failure load, the crushing load that we have to find out. So we just do the test like this, that we put the, keep the cube in between this say one and we do the test. Then we find out the failure, the different cracks it will come, and I have just given, we do not go up to that, but it will crush like this. So the thing is that that one hand which is the in your say, just coming to the previous one, let me show you. So this one, what will happen, it will, if you add the load, it will go move on like this and it will go only up to failure. So from there you can definitely you can find out, and it will not go beyond that, then it will go back. So from there you can find out the strength, that your say crushing load you can find out, and from there you can say that what is the failure load, and from there you can find out that what is the strength, how much you have achieved, that particular load you can achieve. This one say we are having in our laboratory say 60 ton, this particular machine can take say maximum 60 ton, then 120 ton and 300 ton, maximum it can go to 300, because these are 3 different scale. So we can, depending on the situation, that concrete we can go to 60 ton, whether we shall adjust it, or 120 ton or say 300 ton. So this is your that another machine where we do the testing for steel. Similarly, we have to do the testing for steel also. So steel bar, that we put it like this and we give the tensile load. For concrete we do the compression, for steel we test it for tension. So that we put the bar like this, that a closer view, and where we can do, and this one also the load will be such that it will just simply tear it out. This particular one, whenever we shall do the test, it is not the, there should be a neck formation, and finally it will just simply tear it out, and then we can find out the failure load, and also we can find out the elongation. So that is also equally important, because that one will give us the strain. One is the stress, another one is strain. So these are the 2 different aspects that we have to find out. This is another machine, this is now computer controlled, this is called Instron. This machine is called Instron. So this one also another universal testing machine, which can do the work for say testing of different parts, say tensile, compression, bending. These are the major 3 that we can do it with this machine, and that is why we call it universal testing machine. I am talking this one whatever available in our department, the structural engineering laboratory. So this is another closer view of that particular one. Okay. Now this is another important aspect, that is called that how, what should be the guidelines, because concrete and steel, these are the 2 different materials. What should be the guidelines? We should have certain kind of fixed rules and regulation, which we shall all of us we shall follow, and so that we shall come to always in a definite result every time. So for that we have that Indian standard codes. Every country has their own standard codes. So in UK they are having their own code, then also American Concrete Institute, they are also having their own code. There is one famous, that is American Standard Testing of Materials, ASTM. So that particular one we have ASTM, they are also having different codes at how to test materials. So these codes, so there are so many codes, and Indian codes having that wealth of information, lot of things we can get it from that Indian standard codes. Just for one thing, that and each code having their own name, each code having their 1, 2, 3, 4 like that. So, can you tell me that what is that IS 1, Indian standard 1? Indian standard 1, that is made for a specific purpose, for a specific thing, that is for national flag, that is for national flag. Similarly, here we are having so many codes, and we shall follow IS 456 revised in 2000. We shall follow this particular code for our reinforced concrete design. So, IS 456 revised 2000, 4th revision, plain and reinforced concrete code of practice. We shall follow this particular code, and that is our guideline. We can consider this is our Bible for this particular one, because the different people can design different way. Where we differs with the say diameter of the bar. One can argue, why shall we not provide that 8 millimeter bar in the column, but the thing is that, but code says that you have to provide that minimum 12 millimeter. So, the thing is that now if one specifies say less than 8 millimeter, less than 12 millimeter, then obviously that there should be, if nothing goes wrong, there is no problem. When something goes wrong, then only lot of debate comes, that why we have used that particular bar when the code says. So, code is the one that which will give us that some consensus, okay, we shall follow this particular guideline and everybody will follow that particular one. So, this is a way that our code will give for different cases. You will find out for different cases it has given different things, different formulas. We have the formulas also, sometimes you can find out empirical, even if we are using empirical based on certain experiments, all those things. So, then also we have to know, and we have to use certain say your guideline, and which we shall get it in this particular code. But there are few other codes. So, that is another aspect, that your say design loads, this is another important aspect. The whenever we are talking that particular one say load, that say for this particular building, we would like to design this building. So, how much load we shall consider, that we have to consider, because somebody can say, okay, it is not the one that from our experience, okay, this is the classroom, it is the capacity of say your maybe say 100 students. So, calculate on the basis of that load maximum say your weight of the any say student, on the basis of that we can find out, but that is not the usual way. We should have certain kind of load, say we shall consider maybe say 250 kg per square meter load, it will come in 1 square meter, 250 kg, maybe say 300 kg, depending on the situation, what type of building, what for it is made, whether it is a public building, whether it is a residential building. So, depending on that we can find out the load, how much load will be there. If we consider, so similarly here also the dead load we mean to say that is the self weight of the structure. When a structure is designed, that time when a structure is designed, it should also take care its own self weight, and it is also enormous, maybe sometimes it is a 50%. The total load whatever you can consider, that imposed load and its self weight, if you consider 100, so self weight will come say 50%. That means you have to consider, that means it has to withstand that its own self weight also, and that for that we need the unit weights of building materials and stored materials whatever we have. This is your say this part 1, that is IS 875 part 1 revised in 1987, Indian standard 875 part 1 1987. So, that code gives code of practice for design loads, and please note other than earthquake, because earthquake is considered separately. For buildings and structures, part 1, that is dead loads, unit weights of building materials and stored materials. So, this one, if we know the unit weights of different materials, from there we can find out the self weight of the structure, the way it is made, the different constituents if we know, then we can find out the self weight of the structure. and it is revised the second revision in 1987, this particular code we shall follow for the self weight. Because design load, that load actually obviously you can understand that load, if you take it different, then your design final design will different. So, that is why that load is also another important part that you have to consider. The other one, that is called imposed loads, and we call it live load also. So, self weight we mean to say dead load, and imposed load we consider live load, because it can live load we mean to say that it can vary, because say orientation of the room of say different tables, chairs, your furnitures, lot of other things, whatever we can fix it one day, that we can change the CG and then we can find out, that is the way that we can do it. So, that is why we call it live load. So, dead load and your say live load, and that we shall get it in this part 2. The other one is called that wind loads. Other one is that wind loads, that we have to consider, because where the structure is being constructed or to be constructed, what is the wind condition over the years. So, on the basis of that we have to find out, and obviously, we have the map of India, where that what is the wind speed at different zone, different areas. From there we can find out that how much pressure we shall get it, how much load we shall get it due to wind, that is called. So, we shall get that part 3 wind load. We do not need it so far, only we need it in the Himalayan terrain, all those things, the snow loads, but generally we do not need it. We need it say dead load, live load and wind load. These are the 3 we get it from this 875 we shall get it. And the other one, since it is a separate one, so we need Indian standard 1893. Right now we are having only part 1. We had one 1984 revision, that is only one code IS 1893. Now, after the Bhuj earthquake, then we have that particular one, because it has given a really an impact, and we are having so many programs on say earthquake engineering in our country, and funded by Ministry of Home Affairs, funded by Ministry of Human Resource Development. So, that is national program, and that one it is really that some kind of awareness is coming, but the code is very old, it is 1984. Now, it is revised at part 1, that is 2002, and that is for criteria for earthquake resistant design of structures, the general provisions and buildings. For buildings, this particular code will tell that how much load you have to consider, because after all that earthquake load you can consider the strictly speaking that is probabilistic, that is not the deterministic load, the load is probabilistic. So, whatever earthquake will occur today, that or past earthquake, on the basis of that whatever load you can calculate, the another earthquake the structure can take, which may be more than the load whatever way it is designed. So, we can say this particular load is say probabilistic, but even then we have to consider in a deterministic manner, and that we shall find out in this particular code. One more important part, that is IS 875 part 5, this one says the special loads and combinations. This is one important aspect that we have to consider, because the combination of load, that how shall we consider that particular load, the different loads. Generally we consider here the dead load, then live load or imposed load, wind load, and earthquake load. So, DL, LL, WL and EL. So, you have to find out the different combination, that combination of load we have to consider. Live load, that is the one that for which we are going to design. Live load is the one for which we are going to design. that means we have to take care this load. This is the load that for which we have to design the structure, but other loads are coming because for different aspects, because where you are going to construct that building, what type of wind load is there, wind speed is there, what type of earthquake load, whether it is that earthquake prone or not. So, all those things whenever we are considering, generally we consider it should be sufficient if we consider say dead load plus live load, because we have to design for the live load only. If we have to design this particular floor, we have to design for this live load only, but only for live load we cannot design, we have to consider the self weight. So, this is your one, this is the primary combination. Without this we cannot design. Whenever you have to design for this load, we have to design for this, you have to include the dead load also. But we do not know where is the structure going to be made, we have to know the where we are going to make the structure, construct the structure, what is the wind speed. So, for that we have to consider dead load and live load obviously there, plus wind load. The other aspect we consider here, the dead load plus live load plus earthquake load. I am giving this one a broad idea, generally we do not consider wind load and earthquake load in the same combination. We assume that the cyclone and your say earthquake will not occur simultaneously, and that is a reasonable assumption, because if we take care both of them, okay, it is good, but we shall not get an economic design. So, that is also another aspect we have to consider. Safety is one important part definitely, but the other aspect also that we have to consider the economy also. So, these are the combination. Also I am just telling in general, but there should be some other factor, all those things are there, that also we have to consider. Now, regarding books, the books which one we shall follow, what are the books we shall follow? This is one book, that properties of concrete, that Neville. This one here you will get the properties of concrete, because you will get in your structural engineering laboratory also you will find out this particular one, that properties of concrete, that you will get it. And then this particular book, because I read this book in my student life also, and in my teaching also I am using this book, whereas both of them actually faculty of our civil engineering department, that Mollik and Gupta, but mainly I shall follow this one, we shall follow this particular book. Varghese also, Professor Varghese also in our departments. There are so many books available in the market and all are equally good, but I am familiar with these books. I am familiar with this particular book, 3 books, but mainly we shall follow this P.C. Varghese, this particular book, that and limited design of reinforced concrete, that we shall do it. So, as a first part we can conclude this particular one up to this, and we shall continue that all different aspects in detail, that materials we shall consider, and then we shall go to that different aspects of design, and finally we shall come up with a problem, say design of earthquake resistant structures, that we shall come with a with one example at least we shall go from the analysis to design, that we shall cover up, and so that we can have the full idea of say design of reinforced concrete structures. Okay. Thank you.